Assalamualaikum warahmatullahi wabarakatuh. This video is for subject ECM 366, Civil Engineering Quantities and Estimation. And in this video, we are going to look at exercise on taking off quantities for the beam. In this video, we are going to solve question 3B. So, Bina Maju Contractor has proposed a new housing project located in Jerantuk, Pahang. Based on the figures, prepare taking off sheet for construction materials, namely concrete work, formwork and reinforcement for all beam and foundation element. So refer to the data below. Concrete cover for beam is 25 mm. Concrete cover for foundation is 40 mm. And sawn timber that we are going to use is 25 mm thickness. So we are going to solve only for beams in this video. So here it shows figure Q3B1. So it shows the plan view for ground floor. And then also have figure Q3B, the ground beam detail for GB1. Then we have figure Q3B3 that shows the ground beam detail for GB2. And lastly, we have figure Q3B4, that is the cross section of pad footing. So first we are going to solve for GB1, ground beam 1. So we are going to calculate for the concrete, formwork, and lastly for the reinforcement. If you look in this figure, there are 4 numbers of GB1. So the first, second, third, and fourth. And then you have 3 numbers of GB2. First one, second, and third. The length of each GB1 is 5,500 millimeter, including the half column here and another half column here. The breadth and depth for GB1 is given 225 for breadth and the depth is 375. So if you look at the 3D figure here, the length of the beam is 5,500 including 2 half column. The breadth is 225 and the depth is 375. So here the breadth will be 225 and the depth 375. You cannot see in this diagram because this one is the plan view. And then for GB2, the length is 4,500 including 2 half column. And then the cross section is here is 200 and then the depth is 335 and you can't see in this diagram because it is for the same reason, because it is the plan view. So meaning that for your column here, the cross section here it will be 225 and then the cross section here it will be 200. So the cross section size of your column will be 200 times 225. When you are going to calculate for concrete for GB1, basically the length here 5,500, you need to minus with 2 half column here because you have 1 half column and another 1 half column here. So the full column is 200. Half column will be 100. So you have 2 half column, so you need to minus 5,500, you need to minus with 200 because you have 2 half column. And then for the timesing, it will be 4 because you have 4 GB1, first, second, third, and fourth. And at the dimension, you also need to put the value of the breadth and also value of the depth. This is the answer. So for timesing, it will be 4. And then for the length, 5.5 meter, you need to minus with 2 half column, which is 0.2, and you will get 5.3. So you put inside of your dimension. And this one is the breadth, and this one is the depth. So to get the quantity, you just multiply the time sink 4 times with 5.3 and then multiply with the breadth 0.225 and multiply with the depth 0.375, so you get 1.79. So you highlight back in your description 1.79 meter cube of concrete. Next, for formwork for GB1, you can do for inner and outer at the same time. So the time sink will be 4/2. 4 is because you have 4 number of GB1. 2 is because you do for inner and outer. So that's why it become 2. And then for the length, 5.5, you need to minus with 2 half column, which is 0.2, and you will get 5.3. And then you need to put your depth 0.375. Basically, your inner and outer is located at the side of your beam here. So we are going to determine the area of the formwork here. So that's why the length you need to multiply with the depth here, 375. Let's say this is inner, so you will have outer at the other side of this beam. To get the quantity here, we just multiply the time sink 4, multiply with 2, multiply with the length 5.3 and multiply with the depth 0.375, and we will get 15.9 meters squared of sawn timber. For formwork, we can solve in a different way, whereby we can calculate for outer and inner side separately. So for the first one, for outer, the time sink is 2, the length is 11.2, and the depth is 0.375. So for outer, the time sink will be 2. So we have the first outer side here and the second outer side here. And then the length will be 5,500 plus 5,500 plus 1 half column here and another 1 half column here. So it will be 11.2 meter for the length. And then you need to multiply with the depth, which is 375 millimeter. And then for inner, the time sink will be 4 because you will have 4 sides of inner for the formwork. And then the length will be 5.3 because 5.5 you need to minus with 1 half column and another 1 half column here. So it will be 5.3. And then you need to multiply with 375, which is the depth of the formwork. So once you multiply, you will get for the outer is 8.4 meters squared, and for the inner side, you will get 7.95 meters squared. So basically, you can choose either way, whether the previous method or this method. Is up to the students, so on which method that you're comfortable with. Right, next we look for the reinforcement. So if you look in the diagram, for the top reinforcement and also for the bottom reinforcement, basically it use the same spec and the same size, which is 2T25. So meaning that we can combine the top and bottom in our calculation. The detail figure here basically referring to this section. Okay. And then if you look at the reinforcement here, basically it tells us that the reinforcement is a straight reinforcement, start from this end up to this end, and it only has 2 bends here and here. So you have 2 numbers of the steel at the top and another 2 numbers of the steel at the bottom. For the time sink, it will be 2/2/2. Right, so for the first 2, it refers to this section. So because the reinforcement just now is a straight from this end to this end, so we assume that we have 2 GB1, and then the second 2, it refer to the top and bottom, because the spec and size of reinforcement for top and bottom is the same, so we combine in the solution. So that's why we put 2 here, and then the last 2, it referring to the number of steel here, 2, and also 2 for the bottom. Right. For the length, because the reinforcement is straight from this end to this end, so meaning that the length will be 11,000, because you plus 5.5 with 5.5, and then you need to add with half column here and half column here, so it will be 200 mm for these 2 half column, and then you need to minus with cover. So if you look at the detail, here is the cover. Okay, so the thickness of cover, if you look in the question, it will be 25 mm. So you will have 2 cover, one at this side and another one at this side. So for one cover, the thickness will be 25 mm. So for 2 cover, it will be 50 mm. So let's say this is your reinforcement. And if you look at the detail here, it will have the band. So meaning that this side, your reinforcement will have band. So the similar will be at this end. There will be also a band. So total you will have 2 band for one reinforcement. Because this reinforcement is T, it made from high yield steel, and for the standard length for the band, if you use high yield steel, is 5.5D for one band. Okay, so if you have 2 band, you need to multiply with 2. So the D here, it will be 25 mm. Total length for one reinforcement, it will be 11.425. So you multiply with the time saying, and you will get 91.4 meter of T25. Next, we are going to calculate for the stirrup. So stirrup is here. It made from the 4-sided of reinforcement. So if you look in this diagram, it will have 2 anchorages. So first, we are going to determine the length for one stirrup. So first, for this side, so the length is 375. So if you look here, you need to minus with 2 cover. So the cover will be 25 mm for one cover. Okay, then you need to multiply with 2. So when you multiply with 2, you will get this side and another side. Next, we are going to determine the length of this side. So it will be 225 minus with 2 cover. And then you need to multiply with 2. So when you multiply with 2, you will get the length of this side plus with this side. So now you will get, when you total up, you will get the total length for the 4-sided. And lastly, we are going to determine the length of the anchorage here. So we have 2. So because it used R, meaning that for one anchorage, it will be 12D. So you have 2 anchorage, it will be 24D. So whereby your D, it will be 8. So when you calculate, you will get the length of your anchorage here. Next, we need to determine number of stirrup, whereby the formula is length divided by spacing and plus 1. The length will be 5.3 because you need to minus with 2 half column. Spacing will be 175 and you need to plus 1. The final answer for GB1, it will be 152.58 meter for stirrup that made from Art 8. So once you can do for GB1, automatically you can do for GB2. That's all. Hope you enjoy the video.